So let's run through the answer to that your turn, and then we're going to do a second example which involves negative angles. Negative numbers in our equation. So I left you with solving cos x equals 0.2. I should have put this detail in, which was for 0 less than x less than or equal to 360 degrees. Now, if I've given you that, first move here was to do x equals cos to the minus 1 of 0.2. When we did that, we should get 78.463041. That's our first of our angles. Method 1, quick sketch. We have to remember what cos graph looks like. We're talking about 0.2 here. So that's there. Our first angle, 78.463, is there. And along here is our second value. Now, the bits of the graph that match are that bit down to there, matches with this bit over here. So we can see that these are kind of mirror images of each other. How are we going to get that? We're going to go along 360 there, and we're going to take away that section to get back to this angle. So we're going to do 360, take away 78.463041. That's going to give us 281.536959, or rounding it, 281.54 degrees. Second option, instead of doing the graph, would be to draw our cast diagram. And as I say, this is something that you'll get more used to seeing. So I'm just going to keep using it. If you like it, it's there for you. This is a cos and it's positive. So they're all positive there and cos is positive down there. Our first angle, our 78 degree angle, is up here. Our second angle we're interested in is all the way around to something like there. And we can see from our diagram we're doing, well, these two match, these are symmetrical. So we're doing 360, take away 78.463041. And that's exactly the same calculation we did over here. So we still get 281.54, same answer. The other thing you could remember is from our first example, try and get that back. I wrote on my diagram, we always do 360 take away x to get something that's down here. So, two ways to get it. Hopefully you had a good go at that and managed to get somewhere. Now, second thing that we are going to do is we are going to solve some equations which involve some negative numbers. Might just zoom you in a wee bit so you get a better view. So we're going to solve sine of x equals minus 0.3. And we're doing that for 0 being less than or equal to x, less than or equal to 360 degrees. Now, this is where our cast diagram and our graph method do slightly different things. If we are doing our graph method, we can jump straight in and do x equals sine to the minus 1 of minus 0.3. That will give us one of our values, but it won't give us something that we actually are looking for. That will give us minus 17.457, etc. degrees. Now you'll notice this is not between 0 and 360. So let's make sense of that. Well, our sine graph does something like that, but it also extends over here. So our minus 17 angle is relating to a value over here. Our next value where that happens is along here. Well, this bit we've taken 17.457 away. Here we would equivalently be adding 17.457 onto 180 degrees. So the first angle that's going to fall in that region is 180 plus 17.457. And if you do that, you should get 197.457. So that's one of our two answers. The other one is along here. Well, we can see that we took 17.457 away there. It's the same as doing that there. So it's the same as taking it away from 360. So, or 360 take away 17.457. What does that give us? Well, that gives us 342.543 something, which is 342.54 degrees if we round to 2 decimal places. So if we're using our graph method, that's what it's going to look like. If we're using our cast method, it's going to look a very little bit different. We generate something called the RAA. Now that stands for the relative acute angle. Now it's more complicated than it actually is, makes it sound more complicated. We do sine to the minus 1 and we take this as a positive. And we follow that through. So that gives us 17.457. Now in this case, that doesn't make a lot of difference. The minus is the only thing changed. When we're dealing with a cos, you'll see it makes a substantial difference. We're going to draw our cast diagram. So, where is sine negative? Well, it's negative not here because they're all positive here. Sine's positive here, so sine is negative here and it's negative here. Now, for this section, we do 180 plus our relative acute angle. So that's 180 plus 17.457. In this section, we always do 360 minus our angle. In this, we always are using that relative acute angle here. So 360 minus that. And that gives us our two answers that we had before. As I say, when you're dealing with a cos, you'll see there's a little bit more difference between these. Or we get 342.543 to 342.54. You'll see a bit more difference between these. They still give the same answers, but you will see that there's this value here is more drastically different when we're dealing with a cos. So what I'd like you to do is have a go. Use one of the methods. Don't try and use both of them. Do a little your turn, and then I will answer that in a minute. So solve cos of x equals minus 0.7, and I'll go through a solution to that. If you pause your video, then I will run through a solution to that in just a moment on the same video, but just pause, have a go, and then unpause, and I'll run through it. So let's run through the solution to that. Now, method 1, we just fire in, we go x equals cos to the minus 1 of minus 0.7. That gives us a value straight away. That churns out a value for us. And the value that churns out is 134. When you put this in the calculator, that is 134.427004. We can draw our graph. There's our cos graph. We're looking at minus 0.7. That's way down here. There's our first value. So that one's 134 point, etc. That section of the graph there is symmetrical to this section of the graph here. So looking at our graph tells us if we come from 0 along to here, it's exactly the same as doing 360 back to here. So our other value, or x equals 360, take away 134.427004. And we can work out what that is. Put that in the calculator, you get 225.572996. And we'll round both of our answers, so that's 134.43 or 225.57. Now, second method, our cast method. Instead of working x out straight away, we do our relative acute angle. Cost to the -1 would be good, of 0.7. So the difference there, we're not putting the negative in. And this gives us something drastically different. If you do that, it gives us 45.572996. And we'll see how that relates in a second. So doing that, where is cost negative? Well, cost gives us negative values up here and there, because it's positive there and it's positive there, so it must be negative in the other two. This is always 180, take away our RAA. And this one's always 180 plus our angle that we've got. So that is 180 take away 45.572996, which gives us 134.427004, which rounds to 134.43, which is good because that matches what we got up here. Or we get 180 plus that angle that we got. And if we do that, we get 225.572996, and we can round that to 225.57 degrees. As I say, I don't mind which method you have used. Both of them give us the same answers. It really is a choice on what you find easier to understand. This is quite methodical. It's always doing these calculations. This requires a bit more interpretation and looking at the graph to figure it out. Now, we have one more video coming up after this one, which is going to focus in on solving with radians instead of degrees. So very similar processes, but we're going to be dealing in radians.